Hello, everybody. Welcome to RockSim Live. Um, Hopefully, everybody's not too tired from all the turkey and everything yesterday. If you're not from the United States, yesterday was our American Thanksgiving, where people come together and eat a lot of turkey and potatoes and all the things that make you feel full and very tired afterwards. Um, so Tim is gone this week because he went to visit family. So he isn't here. So I'm here instead, running everything. Um, and oh, I'm clicking all the buttons, the wrong buttons. I haven't done this for a while. Um, so yeah, I have a couple questions that people emailed in about, and if you guys have any questions, just feel free to drop them in the chat. I don't know how many people will be joining us today. There may be a lot of people who are sitting around doing nothing, or there may be lots of people out trying to hit all the deals, or refreshing your browser for them. So we'll see, but we will still record this with our lovely selection of people. So just say hi in the chat. I'm looking at the chat over here. So far, Rick shared a turkey, which is about right for this week. Hopefully you can hear everything. I'm trying a different microphone than we've used before. So yeah. So to get started, I will talk a little bit about this beauty here. This is the Katana Junior. We've released the Zephyr Junior and the Peregrine Junior, so you knew it was coming. The Katana Junior, I am crossing my fingers, hopefully will be released this afternoon. We're frantically cutting, like laser cutting the last pieces and getting everything put together. So if you don't see it today, it'll be out probably Monday. But we've been trying to get it out for you guys because there's been a lot of interest in it. So you can see it there. It's very nice looking. It's a BT-70 rocket, just like the other two. But the cool thing about the Katana Junior, this so I don't knock it, is that it comes with a full eBay in it. Just like the regular Katana Junior, there is actually an electronics bay in here. I'm not going to pull these out, but there's a sled. It comes with a sled and the bulkheads and all that. Comes with 2 parachutes. So you can fly this puppy on dual deployment, a BT-70. So it's got a 29mm motor mount as I hit the thing. Which is why the dual deployment, because if you put a really big G in here, or if you're brave enough to throw an H in here, you can use the electronics to still get your rocket back. But you can also fly it on smaller 29mm motors, or throw an adapter in and fly it on like the D12s and things, the smaller 24mm motors. So super cool. We're super excited about it. We worked really hard. It's got really detailed instructions, not only for the kit but the eBay and everything. So yeah, be looking for this in the next day or so. We're really excited about that. So I will jump into questions here. I got people. Thanks, Terry. Terry says, hey, the brainy purdy Rocketeer is back. I appreciate you calling me all of those things. And I got more people jumping in. Happy Thanksgiving from Las Vegas. And Johannes is back. And Chuck is here, and he gets to watch it live. Hi, Chuck. I got your emails. We'll talk about them today, too. So I'm so glad everybody's able to join. So the first question I have is, we had Carlos emailed in and asked about whether or not RockSim can make an Estes mean machine that has a launch rod that's internal. It would be going, but not going through any part of the motor mount tube. Imagine internal launch lugs and drilled holes through bulkheads and anything else needed. And then the launch rod as long as you like, just before it does, so it doesn't hit the nose cone. So what he's asking is, can you, if you're not familiar with internal launch lugs, which are very rare, this is really, really tight. So normally on most rockets, you have a, just checking my messages here. You have a launch lug that's on the outside of the rocket. And that makes sense. It's easy to slide on your rod. You put it there. You don't have to worry about hitting anything. This one's a little crooked with the removable plastic rivets, but that's standard. That's like most of your rocket kits. But you could potentially take your launch lug, actually put it inside the rocket. So what you'd have to do is you'd have to drill holes up through like your centering rings and your bulkheads, and you would run your rod up through the inside of the rocket. Obviously, you're limited to whatever your forward and ending point is, which might be your nose cone, or could be a bulkhead, or could be something depending on how long it is. The Estes mean machine is really tall. We'll pull this up here in a second. So it makes sense for that one. Doesn't really make sense for the shorter rockets, but for the really long ones, you could, do something like that. So he's asking, how do you do this in RockSim? Because you can't put launch lugs inside tubes, basically, for that. So we are going to pull up here. Let me share my screen here and pull up my RockSim here. And then I'm going to pull up my Estes mean machine. Okay, so this is the Estes mean machine. And as you can see, it's really long and skinny. If we go to the 2D view, it's 79 inches. So, you're talking like 8 feet, is that right? 80, not quite 8 feet, like 6 feet. Man, math is hard today, the day after Thanksgiving. So this is the mean machine rocket. So if I went here, if I said, hey, I want to put a launch lug on the inside of my tube, and you want to do it, you think you can do it the standard way, you'll go to your body tube and you'll click launch lug, and you pick a launch lug. Just pick our 1/4 inch one. And as soon as you add it, you'll see, no matter what you do, you can change the location on the outside. You can see the little blue thing going around, but there's no way to move it inside that tube. RockSim makes some assumptions, uses some basic things that everybody does, can't do the fancy things. And so it makes the assumption that your launch lug is always going to be on the outside of the rocket. So how do you put one in there? I should delete that random launch lug that's at the very top of my rocket. So instead, what we'll do is we will find the bottom body tube here, or I guess you could put it wherever you could put it in the middle, but we'll go maybe in the middle so we're out of the way of the motor, all the motor stuff. So we've got this body tube here. And so what we're going to do instead of putting an outside launch lug is we're going to do an inside tube. So it's just like, basically it's going to be like putting on a motor mount tube. So we'll go in. The only problem is you have to make your own tube. So let's see. I don't know what off the top of my head. Obviously the internal diameter is 1/4 inch. Going to be 1/4 inch because it has to fit. Actually, it's probably slightly bigger. 286. And the outside diameter of the 1/4 inch launch lug is 0.328. And the length is 3 inches. I know that one by heart. And then the location, and then we can just drag it or type in wherever we want that launch lug on that internal tube. Right now, you're just positioning it like front to back. That's all we're doing is like where do we want it on the rocket? So if we want it here, we're just going to put back, a couple inches. We kind of split the difference there. So now we have our tube, and it's paper there. And something, oh, I'm missing a decimal. I was like, how is this negative grams? There we go. That looks much prettier. And if you want to know, if you don't have these dimensions, I literally just pulled this straight from the Apogee website. So I just went to the 1/4 inch launch lugs and we got all that info right there. So we have added that in. So then the way to put it off center here is you're going to go to the radial position, and your radial distance will be the distance from the center. So let's I'm gonna make this screen bigger so it's a little easier to see. So right now our launch lug is in the middle. It's that blue ring right there. It's in the very middle of the rocket. Obviously that doesn't work because you couldn't put the rod up through the middle because you have a motor in the way. So we are going to increase the distance, and you can find out what your kind of internal body tube is, or just drag and kind of drop. I'm just gonna drag in. It's a little bit too far. Nah, good enough. So now our 1/4 inch launch lug is sitting right there. And then if you want to move where it's on the tube, you can just rotate it around or type it in there. We'll put it right here so that it's kind of out of the way, because you want to, well, I guess you don't have to worry so much about fins there unless they're through the wall for some reason, but in this kit they're not. So there you go. And then basically that's it. You have your launch lug now. You can delete though. This has 2 launch lugs in it, so we'll delete here, aft launch lug, delete there. And then actually I want to come back, and this tube, we just called it a body tube, but that's confusing. Internal launch lug. Always be specific when labeling your parts. Your future you will thank you for now yous making the effort. Because later on you'll be like, why do I have this random internal tube that's off to the side? And you'll think somebody messed up my file, or what was I doing? And now you're like, oh right, this was the time I did the internal launch lug. So why would you do this in RockSim is kind of a question. RockSim doesn't care in terms of like center pressure, center drag, other than the weight of the actual part. It doesn't really care about internal parts for calculating, other than, like I said, the weight and where the weight's located. So other than like you putting the launch lug on the outside versus the inside, your drag will go down a little bit because your launch lug is on the inside. That would be one reason to put it in there inside. It's a lot of extra work just drilling all your holes and making sure all your holes align, because some of them you might have to drill before you assemble the rocket, because if you've got bulkheads or something higher up. But the reason you would do this in RockSim was, say you were building this Mean Machine kit and you want to do this, and you want to do your own centering rings, or you want to know where those launch lugs go. Now that you have this location, and you could even make it longer or whatever, you can then use this to do a template. So you could do a centering ring that has a hole in the right place for that. So in that case, you need to put it where a centering ring is. You need to drag it. Right now we just have it floating in the middle. But if you drag it where a bulkhead is or a centering ring is, then when you go to print your template, you have a hole and you know where the launch lug goes. So that would be the biggest reason that you would want to do this in RockSim. You can account for the weight, but it's not a lot of weight, so it's just up to you. So yeah, that was Carlos, right? Carlos that asked that. So Carlos, that's what you do to do that, is you would forget the launch lug piece in RockSim and go straight to inside tube. And that's anytime you want to put anything inside your rocket, that's kind of a placeholder. You could use a coupler. You can't offset couplers, but if you're just trying to make spots, you could just do a mass object. If you don't care about templates or anything and you just want to account for the weight and where the weight is, I wouldn't really bother with an inside tube. I would just go straight to mass object and put your mass object wherever it is to account for the change in weight there. But if you want to be super accurate, you can definitely do that without a problem there. Oh, I still got turkey brain. So I just check in our questions. We got people talking about all their food that they're eating. Terry asks, are we gonna be able to simulate repulsive landing in RockSim? Terry, I'm not exactly sure what repulsive landing would mean. The only thing I can come up with is more like oh my gosh, words are hard. sort of like the gimbaled motors that they're playing with right now, and the word is escaping me for what that's called. But so like you would have a motor fire as you're coming down, like the real rockets do. So if you want to explain what you mean by repulsive rocket, repulsive landing, Terry, a little bit more. Tim might know what that means off the top of his head, but I don't. And the answer to your question is probably no, just based on what I would assume it has to do with. Um, but right now we're just trying to get the basic, get standard rockets, standard things kind of going, and working on things like that, and obviously bug fixes as they come up too. So I don't know feature wise what's coming next for the launch visualizer, honestly. There's always little things that pop up, and Tim usually has most of that to do with working with the programmer and going back and forth. So I know long term kind of what we're looking at, but short term I'm not sure for that. And then you got a whole debate about the Estes Mean Machine and Estes kits there. So yeah, Carl, this was just asking, and you wouldn't, like I said, this is so long that you could do an internal launch rod and still have a good, 3, 4, 5 foot launch rod, assuming you have room for, your parachutes and everything. So it would work for that. So next question. So Nathan was asking about, he did a simulation of his Lock 5.5-inch Goblin in both Open Rocket and RockSim. And then RockSim had the rocket going 1,000 feet higher with the same simulation, same parameters than Open Rocket. And then he changed the setting in RockSim, and now RockSim is closer to Open Rocket. So he's asking kind of what that means for those two, like the checking and unchecking and the software. So we don't deal with Open Rocket. We don't really mess with it or test with it or anything. So, and we don't know their code really. So I can't answer specifically about what Open Rocket is doing or how that works for that. But for RockSim, I went looking for this because I was trying to figure out. I don't really. The answer is I don't know. So I went looking to do research today, and what we can see, I'm going to open up the Katana Junior here, and this is sitting very funny. Here. So when you launch a rocket, you go up here and you choose your engine, and I'm just gonna do an F20. It's a nice kind of solid motor. And you click launch and your rocket launches. So, okay. How do you know what the CD is when you do this? Because the CD is this coefficient of drag. And so like that is, what is the drag on the rocket like? And I keep pointing to the Katana and you guys can't see it. I just realized. So in RockSim, under the rocket menu, there is CD analysis. And actually I've gone a step too far. First here, so you've got all your settings here, all your different things. One of the options is CD override. So you can override the coefficient of drag of your rocket. Say you've flown it a bunch of times and you've, got altimeter data that says this rocket, this specific rocket goes this high every time I fly it. And so you're able to back out the coefficient of drag for that. There's math, you can do that. I think we have a couple newsletter articles about that for like the competitions that kids do and stuff, trying to zero in on your altitude because you want to know how high your rocket goes. I mean, we all do. We all think, I'm going to fly this rocket. RockSim says it's going to go 1,000 feet. Is it really going to go 1,000 feet? I don't know, and so we've talked about this before when I've been here, and I know Tim talks about it too. RockSim is only as good as the data we put into it. So it has to make assumptions. Every rocket's different. Every weather is different. so there's just so many different variables when you fly a rocket. So RockSim does the best it can, but it has to be. So, if your weight's not accurate, if your center of gravity is not accurate, if your rocket's not, we get a lot of people who are like, who send files sometimes and they're like completely wrong. They're like the length's wrong or whatever. And it's like, well, I mean, you can still play with that, but your results are going to be only as accurate as your data is. So RockSim has two ways that it calculates the center of the coefficient of drag. I keep wanting to say center of, and then I run out of words. The coefficient of drag. For most rockets, I think the standard kind of across the industry is 0.75. That's what most people use as the like default coefficient of drag. It must be kind of the average of kind of a normal shaped rocket, for that, not going supersonic or anything like that. So 0.75. But on this screen, there's also the option to calculate CD at simulation time. So if you turn this button off, it's going to use 0.75 as your coefficient of drag. And it's going to do that like solidly. It's 0.75. If you check this box, it's going to calculate your coefficient of drag during the simulation. Great, that sounds like it's probably more accurate than some random number I just plugged in for that. But how does it do that? What is the math formula for that? What is it, how does it come up with those numbers? And that's what I went looking for, because I wasn't sure where that was or how to look that up. And so in the rocket menu here, there's CD analysis. And if you click on that, it brings up this window called drag analysis. And then it has the information for a sustainer, one booster, sustainer, two boosters. So if you have a multi-stage rocket, since this is a single stage, it's not clickable. And you'll notice right now, everything's 0, 0, 0. The predicted CD is 0. Down here at the bottom is a velocity bar. And you can type in a flat number. You can drag it here. And what it is, so you can see it says nose plus body, base, fins, lugs. This is where that launch lug being on the outside or not being on the outside. Anything that's kind of on the outside of your rocket counts towards your coefficient of drag, because it's going to be, anything that's outside is going to hit air, basically. So if you think about like a sports car that's super streamlined, that has all the little like spoilers that help the air move, and like the mirrors are all real tight or don't exist, or the less things you have sticking out, the better the drag is for speed and altitude. So what we do is, as you pull this bar across at different speeds, so if my rocket's going 41 miles per hour, this is the coefficient of drag. It's using the coefficient of the nose and body, the base, the fins, the lugs, and it puts that all together and gets a predicted coefficient of drag of 0.25. So as you increase speed, there's a point at which you'll see the CD goes down because it's going faster, so it's cutting through the air more efficiently. And then, but all of a sudden, we hit this like right around here, so right around 700 miles per hour, it suddenly starts going up again. And I don't know if you've ever heard people talk about this all the time, but like when you're driving your car, just a regular car, not a sports car or whatever, they say to drive like around 55 miles per hour. Don't know what that is in kilometers per hour off the top of my head, but that's the most like gas efficient speed. At least that's what I've heard, is somewhere between like 55 and 60 miles per hour is the most gas efficient. So if you're below that, you're not getting as much gas efficiency. And if you're above that, you're losing gas efficiency again. So even though it feels like going 80 miles an hour is actually, it's getting you there faster, but it's actually creating more drag again. So kind of the same idea here, I'm guessing, is that, there's a sweet spot of speed versus all the things that stick out. And then you kind of reach an optimized thing. So where are these, like, what's the math formula behind this? That I don't know. I would call that proprietary, and in the software, it may just be a standard coefficient of drag. All of the math that's in RockSim is in a book, it's pulled out of a book called Topics in Advanced Model Rocketry, which is no longer in print. Again, it was originally printed in like the 70s, and then it went out of print, and then we were able to get it back in print, and then they don't make it anymore either, but it's like this thick. So if you really want to know all the math that goes into RockSim, it's a book this thick of calculus. So be prepared for some fun reading there. But so that is how you can see kind of the differences. So and then the other thing you can do, this was the other thing I was playing with. So I'm going to leave this checked. This is going to calculate the CD at the time of simulation. So I'll choose my engine. Oh, I already chose my engine. And we'll launch it. So if I go up here to the flight profile, so this is the little cartoon of the rocket flying. If you click over here on the details tab, you can see all the data as it changes as time passes. So we just kind of click and drag, you can see all the different values change. So we are looking at the coefficient of drag, which is right here. So I'm going to leave that at the top. So this is calculated. This is not that fixed number. If I drag this, you'll see on this rocket, the coefficient of calculated is like 0.4, 0.40, 0.41, 0.45, 0.5. And then once apogee happens, it is using the coefficient, a fixed coefficient of drag, and for that. And I believe that is from the main parachute. Yeah, so the coefficient of drag once the parachute pops out is set in your parachute settings. So like you notice it went straight to 0.75 there. Is that accurate? Again, it's a default that we just kind of go with. You can change your coefficient of drag in the parachute or your descent rate here. But if you know your coefficient of drag of your parachute, you can change that here. But 0.75 is kind of the standard. So now let's do this again, but I'm unchecking this box. So we're just saying the coefficient of drag for the rocket is 0.75. And we're going to launch it again, same exact motor. Just look at this, there's a difference of 500 feet here. And if we watch the little cartoon again and do this again, you'll see it's 0.75, 0.7. It'll vary a little bit, and then it bumps just at apogee for a second, and then the parachute pops out and we're 0.75 again. So, but remember on the previous one using the calculated coefficient of drag, it was saying it was 0.4, 0.5, somewhere in that range. So his question basically is which one's more accurate? And the real answer is, I don't know. It would be basically that's a good time when you fly your rocket and then see how it performs that first time and see, which one it's closer to, because it's still using data that you've given it either way. But that's how you kind of can look at the differences between sort of the default, like everybody picks around 0.75 because it's kind of the average for most rockets that aren't odd shaped or extremely long or extremely short. And so it works for most of the cases. But as you get flight data, then you can start backing out the coefficient of drag and saying, well, actually, my rocket's kind of streamlined and there's not much on the outside and the fins are really aerodynamic. And so my actual coefficient of drag is that 0.45 maybe. And so then you can put that in, run your simulations and get more accurate data. So yeah, everybody's number one question is how accurate is RockSim? And really there's a bunch of assumptions. There's a bunch of human entered, parameters for your rocket. And so it's all kind of at the end of the day, it's just all kind of a guess, because you could have everything perfect in there. And then your rocket, when it flies, hits a thermal at 300 feet. And thermals, there's no way to kind of, for once the rocket's in the sky, you've got wind blowing and could be blowing in, all the different directions, could be changing direction at each altitude. You've got warm thermals. So there's just so many things that go into it beyond just like the basic stuff for there. So looking at questions in the chat. Okay, Rick asks, can we see the Katana Junior on the site yet? So if you sign up on our website, we've got our regular newsletter, and then we've got the industry updates newsletter. So in the industry updates newsletter, if you go here, industry updates newsletter, And basically, I kind of call it the gossip column a little bit, and it's people, different manufacturers announcing things that are coming or things that were just released. So especially if you're not on like the Rocketry forum or anything, it's a good place to get kind of the scoop on what's coming next. So I did announce it Wednesday in the industry updates newsletter. The kit itself is still not turned on live unless you have the direct link. So I will maybe drop the link in the chat here towards the end so you guys get a sneak peek because you joined my RockSim live today. Thank you for that. So I'll sneak in a link here at the end for it. Rick. Carlos, we just answered your question and he just joined in late. So Carlos, you'll have to go back and watch the beginning later. And Johannes asks, anyone notice Michelle works on RockSim, it suddenly runs much smoother than Tim's. So I don't know if you guys we use a software to stream, and it uses a ton of RAM on the computer, like a ton. I looked at it right before I started and it was using 120% of my RAM. I don't know how that's possible, but it was using 120% just for the streaming program. So, and then depending on what program you're using, RockSim's not so bad, but the launch visualizer could sometimes use up some RAM too. So when you get all of those running, it's a lot of pull on the computer. And it also heats the computer up a lot. I use a special little fan under mine to keep my computer cool. I don't know if that's the difference between mine and Tim's computers because they are the same computer otherwise, but yeah, I do notice that too. And I'm not sure why it runs better. Tim's thinking so hard that even his computer is getting hot from his brain going. Yeah. Okay. Okay, just looking at the other questions. So Rick, you did see that link for it. Yeah. So Rick signed up for the Industry Updates newsletter. So you get the scoop. We will announce it Tuesday in the regular newsletter too. So if you are in a hurry, you can get it then. Also, all new products to our website are actually announced on the homepage. So if you go to our homepage and you scroll down on the page, there's a new product section here. So when the Katana Junior goes live, it will be the first thing in this list. This week we released these really cool round lifting eye nuts. If you do any sort of like dual deployment or you have anything where you have a bulkhead, these are great. We discovered them. Somebody sent us a kit or something that had it, and they're really, really cool. Estes just released a couple of new motor delays for 13 millimeters. Those are really great for if you fly like small but heavy or really light stuff. North Coast just released a launch controller. We have our super cool Christmas ornament that is based on the Halloween rocket we had released. And if you order this week with the coupon, you can actually get it free with your order. So I will drop that coupon code here in a second. So this is the place to go if you ever aren't sure. It's also in our menu. If you go to shop and on the right hand side, there's view new products, and that will take you there as well. And that will show you all the new stuff. The gliding parachutes that just came out a couple weeks ago are on there. So yeah, that's the place to get the scoop on the new stuff. If you're like, I think Apogee released something, but I don't remember how to get there, or I deleted my newsletter, go to the homepage and you'll find it there. Okay, so then the last question I have emailed is from Chuck, who's with us. And Chuck had a question about the launch visualizer. So he is having problems where when he uploads his rocket to the launch visualizer, it's not working. He is getting it like acts like it loads, but then it just doesn't. And so show you guys. So he says this little thing, it says the simulation is running. So he actually gets it uploaded and then he tries to run it and it doesn't work. And so what happens is after it thinks it, pretends to run, you get this nice little screen here where instead of see here how you can see the rocket on the pad, you just see the Earth. So something isn't right there. So I asked Chuck to send me the kit files that he was having problems with. And the bad news is, Chuck, I can't recreate your problem. I tested it and they're working fine for me, I think. So I'm going to upload. This is one of the problems. What it is, Chuck is taking files from like our website or from files from our RockSim, and then he's editing them to match his actual rockets. So he's, changing the coefficient of drag or oh my gosh, now I've been talking about CD so much. The center of gravity. He's adjusting those for his real life rocket, which is great. The RockSim files are based on our display rockets, which sometimes people forget to put the parachute in and then they weigh it and it can be light, or so they're always pretty close, but you never know. It's always good to check your one. So I've uploaded the new file, which is this Dare Big, got me going, Dare Big Red Max, or in this case an Ed Max. Choose an engine. And Chuck, if you do anything special with this, let me know. Like if there's a specific motor you're noticing it on, or if you set any weird settings in here. So I've chosen a motor here and a launch visualizer, and I click go, and it's going to take 65 of my credits, and it's running. But then there's the rocket. It's right there. And then I go play, and boom, it's flying just fine. So I'm not sure why it's not working, Chuck. One thing I would say, if you have a problem with the launch visualizer, try it. You have something that doesn't work, and you're not in a rush, like maybe you try it the next day or something, because there are some times where Tim will find a bug and he'll ask the programmer, say, hey, I found this bug, and they go, oh, okay, and they fix it. So sometimes we catch them really fast and they're able to fix them. That's the best part about RockSim, or the launch visualizer being on the web, is that if we find a bug, we're like, yay, let's fix it. Okay, done. Whereas RockSim, the desktop software, we have to package it, fix the bug, test it, and we have to go through a couple tests, and then we have to package it and then release it to everybody, and then you have to update your software, and it's just a pain to do that. So that's why those don't come out all the time, because it's just hard to do all of that. So yeah, so Chuck, we can try a couple of them. But I have yet to have problems with any of these three. He had a Peregrine copy that he did. And the other thing, like we were just talking about CPU and the pull on your computer, it's possible that these just use a lot. Like my fan is running right now. It's running pretty hot. That like some computers can handle it better than others, and I also am on a Mac, so it's possible it's a Windows. I didn't get a chance to test it on the Windows, so I need to do that when we go. Angle it a little bit just to try some different things. And that's interesting. It says it's 288 degrees. We must have here in Kelvin. That's useful. I was like, wait a minute, that makes 0 sense. Just 15 degrees Celsius at 59. And then we're in a bar. No, those aren't loading. I'll have to check that. Okay, so we're going to launch this again, this Peregrine this time. But see, I'm getting the... Okay, so that did work. So going back to that email image you sent me, check. So you're seeing that after it's done. See, this is where Tim goes, isn't it fun troubleshooting, guys? And it is kind of fun to like try and figure out, but it's more fun when you can kind of hone in on it. One of the things, if you guys know software at all, if you're programmers or you've done with anything before, is the biggest thing with software is you have to be able to recreate it. If you can't recreate the problem, then you can't really troubleshoot on how to fix it. The other thing that's interesting is that his URL is different. It makes me wonder a little bit. Why would it be? Just like clicking on things now, which is helpful. Let's not do 1,000-second delay. That seems not useful. I'm wondering if it's something's not loading right to begin with, because he's seeing this, he's seeing this little globe here, which is odd. But if you look at his URL, it says rocksim.com/design equals Peregrine 2% or %2 or Peregrine. That's interesting. So Chuck, I'm not sure what's going on. I'm going to try this on the Windows computer. Don't know if I'll get to it today because I have to take the mail because Tim's gone too. I will try once I get out of here. I gotta check on those katanas and make sure they're getting built too. But I will look into it a little further too. One thing about that URL that we were looking at is it whenever you see the that %2 or %20, what that means is there's actually a space in the file name. So you might, when you upload it, it shouldn't matter, but you might try like making sure there's no spaces on it too. I can't imagine that's really the problem because like this has a space in it, so it shouldn't be an issue, but that would be the only thing I can kind of come up with on the fly. So, yay. Okay, looking at the chat comments here. Carlos asks, for accurate CD lovers, could we get an article on what vendor accelerometer would be best to get data for RockSim inputs? Thinking altimeter too. The problem is that really there aren't too many altimeters that have accelerometers in them. Most of them are barometric pressure based, which is still accurate, but they're not accelerometer based. So the only ones that we sell that I know of, I think, are the Altus Metrum, the like Telemetrum, Telemega. Everything else is barometric based. So you can still get speed from that. It just backs out whether the altimeter calculates it for you or you do the math for it. But yeah, so that's the problem with that. There just aren't that many there. So Terry says design a SpaceX, BFR, and booster. If you're talking about us specifically, SpaceX licenses their designs, so you can't just make a Falcon rocket or a whatever the new rockets are all called now. All those, the Falcon, the Dragon, all those space companies, Blue Origin, all of them, they all own the rights to their designs. So like Estes just came out, they came out with the New Shepard, Blue Shepard. I always get that mixed up. The funky looking rocket. And then they're working on a SpaceX one, I think, right now. And but they had to go through a whole licensing thing with SpaceX. So as much as we would love to, well, maybe love to, I don't know, do those, it's always a problem. Carlos says I had the planet issue, but it went away after I cleared my browser cache. And that's another thing too. If things change quickly, or if you're making a lot of changes back and forth, clearing your cache is always a good option when you're having problems with the website, any website really. It'll make it load a little slower the first time, but there's just a lot of stuff that's cached nowadays because everybody wants their website to load really speedily, and so they save everything, but if things change, then sometimes it doesn't work or doesn't calculate right. So that's always a good option. Chuck says, as I'm watching, I tried with an Android phone and it worked. The sims I sent were from a Windows 10 laptop. So And he says, I've also noticed in the past Tim has had this issue times. I've seen it before. It's definitely been an issue before. And there's just been different reasons why it hasn't worked. Problems with the files or problems reading the files. Um, we had a problem with Mac files that were uploaded that was fixed, and now it's unfixed. So they're getting that fixed again. So sometimes, they make so many changes that sometimes, you fix one thing and you break another. So um, but yeah, uh, yeah, you can build your own like SpaceX rockets from scratch. Like as long as you're not selling them, you're fine. That's fine. Like you can make your own Mickey Mouse rocket or Marvel rocket or whatever. Like Marvel's not coming to sue you for making a rocket that you're going to fly yourself. But if you tried to sell it, that's where you run into the copyright issues and needing licensing for that. Yeah. So, oh, Terry says to design it in RockSim. The problem is that I'm not super familiar with the rockets enough to like whip one out in RockSim. I'd have to prepare, Terry. I will be here next week as well, so maybe I will try to figure out, how to do a SpaceX rocket for in RockSim for next week, um, for you guys. I'll just need to find, a picture of one at the very least, and then I could kind of prepare a little bit for that, with some dimensions and things. So that might be our fun activity for next week. Yeah, Tim's out of town again next Friday. So Terry, I will try to prepare that for you, too. But yeah, so um, so we don't have any other questions in the chat right now. You guys are all just chatting away, but so I am going to put this Katana Junior in here. This is, oh, that's the demo designs, Michelle. What are you doing? So, whoops, we have the Katana Junior. So, we have our rocket here. It's so pretty. It just looks so nice and sharp there. And we're going to choose a different launch site. And I always like to pick fun places. So I'm going to launch from our parking lot. Why not? It's a holiday. Nobody's working here anyways besides us, so there won't be anybody to get hit with my rockets as they come down. So this is, whoop, this is sliding all over. This is us with the blue roof here. So you can always find us on Google Earth if you look. We have a blue roof. So I'm going to angle my rocket 3 degrees just because. And this is weird. I don't like this. I'm going to do an 8-foot rod. And today it's probably closer to 45 degrees outside. It's actually warmer today. Yesterday was so cold. And crazy windy yesterday too. Okay, so we're going to choose an engine. Let's pick a really big one. An I-205. Why not? This isn't for real, so I don't have to worry about shredding my fins or having my rocket go so high it won't survive. Okay, and then I've got my 2 parachutes here. So we're going to launch the drogue parachute at Apogee. And then the main parachute, we're going to deploy at altitude. We'll deploy it at 400 feet. Okay, and then we're going to go ahead and see, when you're down here, it's got the globe here too. So that's interesting. And now we're going to launch this puppy. But we're not launching a puppy. That would be illegal. It's thinking, and thinking, and thinking, and thinking, probably because it's going really high. Okay, so we're technically actually launching from our neighbor's parking lot. That's close enough. Okay. There it goes, flying over the interstate and schools. And that's where we used to be, over here. That was our old building. That's like 2.5 miles away over there. There we go. Woo, zoom in, making myself sick here. So, it's coming down. So how high did we go? Let's back up here. So about 4,900 feet. If I click on the little data here, this is that. So, see where it lands. Fast forward down here. I'm gonna land back at our parking lot because there's no wind. That's why I don't think I had any wind going. Close to our parking lot. We are about a mile that way. So it landed about a mile away from us. So that's a little far. Okay. So went 5,003 feet. That's pretty darn fast. Let's change it. Acceleration. And we went 888 miles per hour. Yeah, probably a little too fast. Just a tad for this little rocket. But that was fun. That was cool to see where it was going to land from us. I haven't really thought about that part before. You're always interested in where it's launching from, so yeah. So Johannes is asking about doing a grid fin in RockSim for next week. So when you say grid fin, what exactly, because I can think of like 2 or 3 different options for what you mean, Johannes. So what, like, the fins are actually like, they're not solid, they're made out of like grids? Or are you talking about it being more like adjustable, where you can like adjust different pieces of the grid? And for that, Terry says to design a Michelle rocket. I have a couple of kind of fun little rockets that I've done over time. Usually I do, I don't know if you guys are familiar with the TARC competition. It's not supposed to be called TARC anymore. It's the it's the American Rocketry Competition. They changed the name and I can never remember. It's for like middle school, high school students to compete for college scholarships, and they compete all around the country. And then the winner in the United States goes to either England or France. It alternates, and they compete against the British and French team, and I think Japan had a team the last couple of years, and there maybe was somebody else, I think, this year. But anyways, there's a competition, and so we provide like parts packs for those, for the kind of common things. And so every year before the competition starts, I do a test rocket, and I build a rocket as heavy as I can because there's a weight limit, and then as light as I can possibly get it with still having all the information. They have to launch an egg, and sometimes it's 2 eggs, and sometimes the eggs are horizontal and sometimes they're vertical. But yeah, so they do that every yeah. They do that every, so I make a test rocket, 2 test rockets in RockSim, and try and figure out, I do that to try and figure out what motors they might be using so we could stock up and be prepared for motors that they need. So it's kind of a fun exercise. You should maybe try it. If you go to rocketcontest.org, it has all the rules every year. So even if you're not, 13 to 18, even if you're 60 or 70, it's still a fun thing to do. It's like if you did that physics thing in high school or middle school or elementary school where you had to like drop an egg from the roof or make a egg on a ramp, like in a car on a ramp, go and not break the egg. That's what they're trying to do, is not break the egg. And there's different altitudes every year, and there's different rules. Last year they had to go, or they've had to do transitions, so the top's bigger than the bottom. They've had to do horizontal eggs. They've had to do vertical eggs. 2 eggs. One year they had 3 eggs. That was very heavy. The Saturn V anniversary, they had an extra prize if you made your rocket look like the Saturn V. That was kind of cool too. So it just changes. 2 parachutes, 1 parachute, streamers. Every year it changes. So it's a kind of fun exercise, even if you don't build them in real life, to do them in RockSim, and so I do that a lot too. Looking at the chat, we're getting low on time, so maybe clustered multi-stage would be fun. So Johannes is pushing the limit here of how many motors can we stick in one rocket. Oh, grid fin like the SpaceX booster use. Okay, I'll look into that too. Probably not possible in RockSim, but you never know. So I just looked at the Apogee website for Logic Altimeter 2, and it says that it has a G meter and barometric altitude. So you can use a barometric altimeter to back out the center of the coefficient of drag of your rocket. Let's see if I can find. It's called something funny, so I always have trouble finding it. Let's see. That's not what we want. So what I'm doing is I went to the newsletter archive. So this is a list of every single newsletter we've ever released. And then if you know what word you're searching for, you can just do a find on the page, which is like a Command F or Control F, I think, on Windows. And then I'm typing in drag. Drag brakes was what I was thinking about grid fins when you were talking about that, Carlos. And I just looked for, but this says drag. So if you want to build your own Falcon 9 with the Crew Dragon capsule and you have a 3D printer, so that's how we were able to like release a Falcon 9 kit, was there were plans for it and 3D printing STL files and stuff for that. Derivation of the apparent drag coefficient. This actually probably answers the question that I sort of answered earlier. So you might take a look at that article too. I will definitely be taking a look at that article. Drag of tube fins, drag of nose cones, how to determine the drag coefficients of your rocket. So here's a newsletter article there we go. This is exactly what I was looking for. So it's newsletter 303 that will get you the information. So basically, this is called altitude backtracking. That's one way you could call it. So basically what you do is you put an altimeter in your rocket and you actually measure it. Then this is using RockSim to do this. So then you put it in RockSim and you use the fixed 0.75, and then you compare them, and then you can tweak your CD to actually go back and forth to figure out what it is. So that's using RockSim. That's probably easier. I think there might be another article that talks about, or maybe there's more in this one, that actually talks about backing it out, more like other ways to do it. Wind tunnel, that's another way you can figure out your coefficient of drag. But most of us don't have access to those readily. We do have a newsletter article on building your own wind tunnel out of like tubes and a cardboard box. That'll be as accurate as you probably can get without having technical. But so yeah, newsletter 303 is a good one to look at for that, to figure out how to do that. So you can use a barometric altimeter. You don't need an accelerometer based one. I think, but I think all altimeters now have that G switch. It doesn't have a G switch anymore because they've gotten away with that. The old ones had the switch that actually would trigger. Now it just accommodates if you go past Mach 1. So that's what it means by that. So but yes, Johannes, you could actually, or Carlos, you could actually use the altimeter to back that information out there. I told you guys I was going to give you the link for the Katana Junior. It's not, you can't buy it yet, but you can sign up to be notified. So if you go here, you'll notice right now it is sold out, but you can actually put your, click on the link and it'll take you to the bottom of the page, and then you can put your email address in, and then when it's in stock, whether that's today or Monday, we will send you an email to tell you it's in stock. So let me grab that link for you guys so you could sign up if you want. dare. So we got lots of people talking now. We just need a cluster here to stay within the legal limits. Yeah, I'm sure there's lots of limits on clustering. And is there any way to move the launch button on the launch visualizer on an Android phone? It's blocking the button that centers the rocket on the screen. There's no way to move the buttons, unfortunately. They're fixed in their location. They're set up that way. So, whoa. They're fixed there. But I will take a look. Every phone's a little different. So like if you've got like the big giant iPhone versus a little tiny iPhone, or the same thing with like a big old Samsung or like a little tiny, older one or whatever, the buttons they float. So it might be that on your size phone it doesn't work well. I'll take a look. I have an iPhone, but we have a couple people here with Android, so we can see if maybe that's going to be in the way. And we might be able to tweak that. So I will follow up on that. So glad you guys learned things. People are joking about things blowing up. They did not blow up, the chat. So I did say I was going to do that. And then the other thing I was going to do was to drop the coupon code in for the is it in this one? Yes. Okay. So for if you can get here for joining me today, or if you sign up for the newsletter, you get this anyway. So this is absolutely no secret. In the newsletter, you can get this Christmas ornament for free with your purchase. You just put in the code holiday22. This is only good through December 1st of 2022. So if you're watching this in 2024, this coupon code will not work for you. But so you can go to the Christmas ornament, which I showed you how to get to on the homepage as a new item. And or if you just check out and don't add the ornament to your cart, and you type in holiday22 when you check out, you can get it for free. So just do it. My Christmas tree, like most of my Christmas tree ornaments are all the Christmas ornaments every year. So it's kind of fun to have those there. So I sent you guys all the links, and it looks like we don't have any more questions for today. It looks like I have some homework for next week to do. You guys are mean, making me do work ahead of time, but it helps. I appreciate having stuff to prepare ahead of time, like the CD thing. I would have never been able to answer on the fly, but I learned something new in my preparation for that too. And I'll definitely read that newsletter article about the coefficient of drag that we looked at. But thanks everybody for sitting with me today. I appreciate that you all came out and had a good time. And I'll see you again next week. So if you have any other questions, just go ahead and you can shoot them in the email to on the contact us page, and or if you have our email address, you've emailed us before, go ahead and reply back or something. And I will follow up on those things that I mentioned today. And we'll see you again next time. Thanks for joining.